What I'm going to demonstrate today is Newton's third law, along with some other principles of science. And I'm going to be using some equipment here that can be very dangerous if it's misused. So I'm not going to suggest that you try this at home. That would be a very foolish thing to do. Everyone that's in the room will be wearing goggles during this experiment. And I've controlled the explosion that we're going to get here so that I know exactly what's going to happen. I know the type of fuel to use, the amount of fuel to use, and just how to ignite it so there isn't a danger to anyone in the room. I'm actually using the lowest grade of this type of fuel that can be purchased. So if you were to try this at home and go out and purchase fuel, and you were to buy a higher grade, it could be disastrous. So I'm not even going to tell you what this fuel is because I don't want you to try this at home, and I urge you to not experiment with this at all. What I'm going to do is take a fuel that's in here and put it inside this 5-gallon water bottle, which is made of plastic, so if it does shatter, it's not going to hurt. I'm going to mount this upside down on this launch platform and then ignite the propellant. As the force of the explosion goes out the base of this, an equal force in the opposite direction, according to Newton, will cause us to lift into the air. You'll see a fireball of flames. I've taken these 2 bricks and lined them with aluminum foil to help protect the desk from the heat that's going to be generated from this. Now to show you this fuel and how it behaves, right now it's in a liquid form inside this beaker. And in its liquid form it's not dangerous. I can light it on fire without fear of explosion. And you can see it burns quite safely. There's a little bit of a flash when it first went off from the fumes. But it's that safe. However, when I pour it into this, it starts to evaporate very quickly, and it doesn't take much fuel in order to do this. But I'll swirl it around inside here now so it's completely coating this container in a thin layer. That exposes more of the propellant to the oxygen that's inside this. So this has now become an oxygen-saturated chemical, and we know that oxygen is necessary for a fire. So what I've designed in order to light this off is I've taped a wooden splint to this meter stick so I can stand back 1 meter away to ignite it. So let me finish swirling this around in here. It should be fairly well coated now. As I dump it upside down, some of that spills into the trough, which will actually be good because I'll use that to ignite. So I'm going to light this and give it a 10-second countdown, and then we'll see this thing launch off. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Now, I felt a flash of heat back here. You can see it's basically disintegrated and evaporated the aluminum foil. I've also set fire to one of our projects that was hanging off the ceiling there. So you can see there is a bit of danger to this. But it's vaporized this aluminum foil into little tiny pieces. So that's Newton's third law. As the force goes out, the force goes up also. Thank you.